Imagine a laboratory that does not stop when people go home. The lights stay on, robots prepare materials, instruments measure the results, and AI decides which experiment should come next. Without a scientist standing next to every machine, no breaks, no fatigue, and in many stages, no direct human intervention. This is not science fiction. Laboratories like this already exist, and they are changing how scientific discoveries are made. Until now, research has moved at a very human pace. A scientist had an idea, prepared an experiment, waited for the results, analyzed the data, and only then decided what was worth trying next. But the problem is simple. Nature does not offer just a few options. It offers millions. To build a better battery, for example, you do not test just one material. You test different concentrations, different temperatures, different charging speeds, and different manufacturing processes. Each small change can affect the final result. And when these choices are combined, they can create millions of possible variations. One person cannot test them all, not even an entire laboratory if it works at a traditional pace. This is where the autonomous laboratory comes in. It is a laboratory where AI does more than analyze data. It helps decide which experiment should come next. Robots prepare the samples. Robotic arms move the materials. Scientific instruments measure the results. They can measure electrical conductivity, mechanical strength, energy efficiency, stability, and other properties that matter in real materials. Then the algorithm compares the results. It looks at what worked, what failed, and what should be tested next. After every experiment, the system learns. If one combination produces poor results, it is eliminated. If another looks promising, it is slightly modified and tested again. This creates a continuous cycle: experiment, measurement, learning, and then another experiment. This is called a closed-loop system. The important part is that the result of one experiment becomes the starting point for the next one. The difference from traditional research is not that machines are smarter than humans. The difference is speed, patience, and the ability to repeat the same process hundreds or thousands of times without getting tired. A human team might test dozens of variations. An autonomous system can test hundreds or even thousands while constantly learning from each result. And this is not just theory. At the University of Toronto, an autonomous system explored new combinations of materials for solar cells. It helped identify promising candidates much faster than traditional methods. For researchers, this matters because discovery often depends on many small tests. One material may fail, another may improve efficiency by a tiny amount, and that tiny improvement can point the system toward a better direction. But this does not mean humans disappear from research. In reality, the opposite is true. Humans still decide which problems are worth solving. They define what a good result looks like, what limits must be respected, and which directions deserve further exploration. The autonomous system does something else. It searches through the possibilities much faster and removes a huge amount of slow, repetitive trial and error. That is why the next breakthrough battery may not be discovered by one genius working alone in a traditional laboratory. It may come from a collaboration between researchers, algorithms, and robots. A system that keeps testing, day and night, without stopping. And the effects may appear sooner than we think. If, in the coming years, we see batteries that charge in minutes, more efficient solar panels, or entirely new materials for electronics, part of those discoveries may come from autonomous laboratories already working around the clock. This could become one of the most important changes in modern scientific research. Not an AI that thinks like a human, but an AI that helps science move forward faster than ever before.